Hello, good afternoon. My name is Jesus Pino, and I will be explaining the third question. What is the probability that a student passes at least one of the three subjects? First, the probability of not passing each subject is calculated. That is, the probability of not passing calculus is 1 minus 0.65, which equals 0.35. The probability of not passing programming is 1 minus 0.55, which equals 0.45. And the probability of not passing statistic is 1 minus 0.60, which equals 0.40. Since the events are assumed to be independent, these probabilities are then multiplied 0.35 times 0.45 times 0.14, yielding 0.063. This result represents the probability that a student fails all three subjects. Next, this value is subtract from 1. So 1 minus 0.063, which equals 0.937. And this indicates that the probability of the student at least one subject is 93.7%, so 0.937 times 100, which equals 93.7%. In terms of absolute numbers, multiplying 0.937 by 150 results in approximately 145 students. Question 2. What is the probability that a student passes both programming and statistics? To address this problem, we aim to determine the probability that a student successfully passes both programming and statistics simultaneously. This calculation involves the intersection of two independent events. Substituting the corresponding probabilities 0.55 times 0.60, which equals 0.33. Expressed as a percentage, this probability becomes 0.33 times 100, which equals 33%. Hence, there is a 33% probability that a student passes both programming and statistics currently. Finally, to determine the number of students, we multiply the probability of 0.33 times 150, which equals 49.5, a value that can be rounded to 50 students.
Well, the first question asks, if we select students at random, what is the probability that they use either books or educational videos? Well, books equals 114 divided by 215 equals 0.56, and educational videos equals 18 divided by 215 equals 0.32. Books, onion, educational videos equals 0.56 plus 0.32 equals 0.88. The result is 88%. More than half of all students use one of these to the resource. Books, in particular, are the most widely used resource in the group. The second question is, what is the probability of using books and participating in projects? The second question is more specific. It asks about the overlap between two categories: students who use books and who also participate in projects. From the data table, we know that 15 students fall into both categories simultaneously. Well, books, the seniority, participate projects equals 15 divided by 215 equals 0.06. That means only 6% of the students use books and participate in projects at the same time. This is relatively.
Thanks you. I will now address the remaining question from exercise 4.1. Beginning with question 4. What is the probability of failing all three subjects? This question is the inverse of what Jesus calculated in question 3. Rather than asking how likely it is for a student succeed, we now ask, what are the chances that a student fails every single subject, calculus, programming, and statistics, all at once? We already computed the individual failure probability as the complement of the passing rates. Since the subjects are independent, we multiply these three values together. So we have three probabilities. The first one is P of fail calculus, that is equals 1 minus 0.65, and that equals 0.35. The second one is P of fail programming, that is equals 1 minus 0.45, and that equals 0.35. And the last one is P of fail statistics, that is equals 1 minus 0.16, and that equals 0.14. Finally, we have to multiply all results, and we get the percent, and that equals 0.063, and that represents 6.3%. That means 9 students who fail all subjects. On the other hand, we see the Venn diagram of this union of complements, and we can see that all the elements are outside of the set. The probability is just 6.3%. Put differently, only 9 out of 115 students are expected to fail all 3 subjects simultaneously. This is a remarkable low figure, and it underscores an important point. When students have multiple independent opportunities to succeed, the probability of total failure decreases dramatically with each additional subject. From a practical standpoint, these results suggest that the academic environment being studied is reasonably supportive. The vast majority of students are passing at least one, and in the most cases, more than one of their subjects.